It was a time of terror. As the dawn of the atomic age cast its dark shadow across the Earth, a superstructure was built in response, a construction so strong it could survive a nuclear blast. So powerful its electronic eyes reach 37 kilometers into space. 700 tons of dynamite ripped 23,000 truckloads of solid granite from the heart of a mountain to create an underground fortress of unprecedented size. Hidden deep within the Earth, this high-tech sentinel guards American skies against attack. This is the secret world of NORAD. Cheyenne Mountain, a rugged rocky mountain peak rising boldly from America's vast central plains, just a few kilometers from the town of Colorado Springs. Deep within its 100-million-year-old granite heart lies one of mankind's most remarkable superstructures, a citadel of stone, steel, and microchips. Men and women maintain a second-by-second vigil over the skies around the world, looking for any signs that could be the beginning of an attack on North America.
Exercise quick alert! Open up checklist 101-112.
Sir, we got an unknown in the system.
Radar picks up an unidentified object in the skies over central Russia.
DST is reporting an Eastern quick alert from Plesetsk, Russia.
It's traveling fast and heading towards the Pacific Ocean.
Stand by for possible missile event.
CD copies. Intel, what is your
A
analysis?
prompt response is vital to the defense of the nation. Highly trained teams scan intelligence reports to establish the correct action to take.
Sir, Intel assesses this to be the scheduled launch of an ICBM from Plesetsk with impact expected at the Kamchatka Peninsula.
And Intel assessed this as troop training.
Although it's a scenario that has been played out many times before, the staff on duty know that a moment like this could be the one that puts them to the ultimate test.
Troop training. NORAD, U.S. Space Complete, recommend we terminate this conference.
This is the headquarters of the North American Aerospace Defense Command, or NORAD. Members of the United States Army, Navy, Air Force, Marine Corps, and the Canadian Armed Forces staff the NORAD operation centers. They work under the cover of a superstructure whose design and construction are as incredible as its high-tech capabilities. In a virtual world of computers, remote sensors, and speed-of-light telecommunications, they stand watch over the North American continent, constantly scanning instantaneous data transmissions from a vast network of sensors on land, at sea, and in space. NORAD's eyes can not only see the entire surface of the Earth, they also gaze 37,000 kilometers up into the heavens, where they probe 43 trillion cubic kilometers of aerospace. NORAD personnel consider all airspace for 190 kilometers around the outer border of the United States and Canada critical to national security. It's called the Outer Identification Zone. NORAD must know the purpose of every aircraft there.
And as soon as an aircraft crosses the outer identification zone, we start a 2-minute clicker. So we've got to figure out who that track is within 2 minutes. And if we can't figure out who it is, or there's no way to correlate that with an FAA flight plan, we declare the track unknown, and that's when we scramble interceptors and go out and figure out who that is by putting eyes on the target.
Yes, sir. I just want to let you know that we have an unknown over Canada right now.
On a given day, we have anywhere from 6,500 to 7,200 tracks. And we provide identification of every aircraft coming into North America. And that is a pretty sizable task given the fact that about 2.5 million tracks come into North America every year.
Cheyenne Mountain's labyrinth conceals NORAD's military wonders. Its existence has always been well known, as has its tracking capabilities, but its methods have always been top secret. How this superstructure came to be carved out of the inside of a mountain is one of the great feats of engineering history. 15 ingeniously constructed steel plate buildings house the command centers and the infrastructure that supports them through the endless hours of NORAD's vigilance. Stores of water, food, fuel, and a sophisticated air cleaning system provide life support for the complex. It can completely seal itself off from the outside world for more than 30 days.
Well, the first time I got here, I was lost. I really didn't know where I was going when you wander around because it's a pretty complicated complex inside. It's hard for people to imagine all the different levels of, different floors and different buildings that are here, and it's pretty overwhelming at first, but there's just a real sense of awe because the design is incredible. When you come into the large tunnel and through the blast doors and just realize what this was meant to survive, any kind of an attack during the Cold War. And the engineering that went behind it is just amazing to me still.
Getting all the technology inside a mountain presented new engineering challenges. The builders carved 350,000 cubic meters of hard rock from the core of the mountain and replaced it with 7,000 tons of steel, vast quantities of concrete and cabling. But why was it necessary to hollow out a mountain and build this amazing superstructure? The threat of nuclear attack. At the end of World War II, the United States dropped the newly developed atom bomb on Japan. The new atomic age had begun, and with it came the fear of Armageddon. Could anything survive this unparalleled destructive force? To have any chance of winning an unthinkable war, America had to build a command center that could withstand the force of an atomic explosion. With the constant threat of a military strike against America, NORAD was created, the North American Aerospace Defense Command Center. At the beginning of the nuclear age, the technology to build a working city deep within a mountain which was strong enough to endure a nuclear blast didn't exist. No one knew how many problems engineers would face, or how innovative they would have to be to solve them. The call went out to America's most talented engineers, challenging them to create something totally new.
In fall of 1958, I received a call to go to Omaha to meet with a Corps of Engineers to discuss a project. And that's how it all began for me.
I didn't know anything about Colorado Springs, didn't know anything about NORAD at that time.
In the late 1950s, Tom Kiesel and Steve Greenfield were young engineers with the New York firm of Parsons Brinckerhoff. Greenfield had proved his skills on some of his company's toughest projects. He specialized in hardened underground defense facilities, and his work was often highly classified. Kiesel was more of a specialist in tunnel design and bridges. He brought innovative solutions to engineering problems. But nothing they had done prepared them for the mysterious top-secret project of engineering North America's survival. The young engineers and their colleagues were given an unprecedented task: to design and build, quickly and economically, a fortress that could survive the effects of a nuclear blast. For the first time in history, there was a weapon that could destroy the entire human race, a weapon that was also in the hands of America's enemy. In 1949, the Soviet Union detonated a nuclear device. Soviet bombers armed with nuclear weapons were capable of striking North American cities. The nuclear superpowers settled into what became known as the Cold War, a permanent state of confrontation that could instantly turn volatile.
When I was in the regular military, we had very regular military training for the future war against Americans.
Colonel Stanislav Lunev is the highest-ranking Russian military intelligence officer ever to defect. He is currently in the Federal Witness Protection Program.
And I didn't know any other life than to live inside Cold War. We consider all this peacetime as some kind of break, which we have to train ourselves for the future war. Only break, peace break, that's all.
In America, the Soviet threat gave birth to a massive campaign called civil defense.
And cover, dum dum,
You know how bad sunburn can feel. The atomic bomb flash could burn you worse than a terrible sunburn.
There was a turtle by the name of Bert.
While the public was bombarded with civil defense training films, federal and local authorities built shelters and tried to prepare for the worst.
Where we would hire architect engineering firms to go out and identify existing shelters in existing buildings, hallways, and then put up signs that this is a fallout shelter, and then eventually put in provisions, food and water, so that you could spend some time there till the fallout decayed enough to where it was safe to go outside.
This shelter is a real good idea. If we should ever have a nuclear war, we could get a heavy fallout even though we were not anywhere near the target area.
Hey, isn't this nice?
The American public became paranoid, gripped with the fear of Soviet attack. They wondered how much protection the civil defense really could offer against a nuclear onslaught. The key to survival was to detect and stop an attack before it came. In 1957, Canada and the United States formed the North American Air Defense Command, or NORAD, designed to watch over the continent and act as an early warning system against attack by the Soviet Union. To detect incoming bombers, Canada and America cooperated to build a series of radar outposts across the far north. The Dew, Mid-Canada and Pine Tree lines provided early warning of enemy attack over the North Pole, but the new defense system suffered from a fatal flaw. NORAD headquarters was an old hospital building, a masonry structure built in the 1920s. A direct hit from a conventional bomb would raze it to the ground. A nuclear attack would turn it to dust. In 1956, the Continental Air Defense Commander reported that a man with a bazooka passing in a car could put the establishment out of commission. To fight its Cold War with Russia, America had to build something previously unimagined, a hardened command center that could survive the devastating power of an atomic bomb. The first design followed the plan of the Strategic Air Command headquarters at Omaha, Nebraska. The plan combined an above-ground headquarters with an underground combat operations center. But defense planners protested that the design was too vulnerable for a facility as important as NORAD headquarters. The RAND Corporation, a defense think tank, recommended locating the base underground and, if possible, within a granite mountain. Military engineers combed the front range of Colorado's Rocky Mountains in search of a suitable site.
The site was eventually chosen in Cheyenne Mountain south of Colorado Springs, which is a great big blob of granite. And it was chosen because it was the hardest and strongest rock around.
Besides its granite core, several factors attracted NORAD designers to Cheyenne Mountain. It was near the geographic center of North America, far from Soviet strategic bombers, in a relatively inactive geological region, and near an existing military base at Fort Carson, Colorado. The engineers had their site. Their next challenge was to carve a massive structure out of solid granite. Hard rock miners had the technology, but no one had ever tried a project of this scale before.
The whole concept of this structure was to create a series of caverns 1,500 feet under the surface of the mountain. And they were kind of like an egg crate. There were 3 galleries that went in one direction and 3 that crossed them. So there were intersections where the 2 galleries came together.
Work on the massive caverns began in June 1961. the miners made quick progress. In only 1 year, they blasted loose and hauled away 450,000 tons of granite. But suddenly, their work took on a desperate urgency. In the autumn of 1962, the fine balance of power rocked as America found a new threat directly off the Florida coast. Aerial photographs revealed that the Russians had placed missiles capable of carrying powerful nuclear warheads on the island of Cuba, only 145 kilometers from American soil. The world teetered on the brink of a nuclear catastrophe.
We were redeployed to the reserve position very deep in the mountains from our permanent location and received weapons, ammunition, gas mask, special clothes for the protection against radiation and all other stuff. It was good luck of our mankind that we had the chance to avoid this war.
After 13 days of tense negotiations, the Soviets withdrew their missiles from Cuba. Tempers cooled, but the arms race continued to escalate. In the wake of the Cuban Missile Crisis, work proceeded on NORAD with an even greater sense of purpose. The project was put on what was called a wartime construction schedule. It was to be completed as soon as possible. Everyone involved with the project knew what was at stake. The work continued at a furious pace.
Hey, good one, Carl. Finally.
These golfers are friends. They're also the architects of America's most important and protected military installation. In the 1960s, they were the rising stars of the Army Corps of Engineers, charged with the seemingly impossible task of building a nuclear bomb-proof NORAD.
It was an elite group of, well, we considered ourselves elite at least, group of people that were good structural, electrical, mechanical engineers that were giving super challenging problems.
As far as I know, there were no projects designed to withstand the effects of a nuclear explosion.
The most important requirement of the underground facility was its ability to survive a nuclear blast. Before work began, geologists and soils engineers drilled test holes to discover if the rock would support the enormous cavern that needed to be hollowed out of the belly of the mountain. The military engineers had plenty of experience in underground tunnels and mines, but blasting a hole inside Cheyenne Mountain would be like no mining project ever conceived. NORAD headquarters required far more space than a mining tunnel. At first, it didn't seem to be a problem. The miners were very good at blasting and removing massive amounts of rock, but the project required more finesse. The rock chambers had to be excavated to a very specific size, and the remaining rock had to be structurally solid. Normal blasting removes the maximum amount of rock in the shortest possible time, effectively, but it's very destructive. Blasting inside Cheyenne Mountain threatened its overall stability.
Now, before the excavation is made, of course, the joints are tight because you have the massive rock above, which is keeping everything real tight. But once you start blasting, then once you've created an opening, you have a loosening of the joints.
The massive blasting not only weakened Cheyenne Mountain, it left its brittle granite with sharp, jagged edges that could break off and fall if a nuclear impact shook them. Desperately in need of a solution, the engineers called in Dr. Clifton W. Livingston, a blasting expert from the Colorado School of Mines.
The rock of Cheyenne Mountain was very brittle granite, and as such, in the blasting, it broke very jagged corners. Doc Livingston was a rock dentist. He came in and trimmed it up. He was, say, halfway between a quarry blaster and a sculptor of Mount Rushmore. He was much more precise and careful and more expensive. And he used very small charges and very precise drilled holes.
Dr. Livingston's technique of smooth blasting significantly reduced fracturing and weakening of the rock. Livingston precisely calculated the dynamite charges so that the rock fractured only to the desired depth.
When he was brought in, I guess it was sometime in 1961 or 2, there was considerable concern about the security of this cavern. And Doc Livingston took the contractor in hand and directed where to drill the holes and how deep and how much powder to put in them and what sequence to set them off. And he worked on it for 6 months and he had the place looking pretty good. And the Air Force came through to look at this. They'd heard there was all this trouble up here. And they came in and saw the chambers were all nice and smooth. And what's all the fuss about? What do we need this guy for? And they fired him. But he did his job, and he made a major contribution to this project.
But it was not enough just to smooth the cracks in the cavern. To withstand a nuclear impact, the hollowed-out sections needed to be strengthened. A special type of mining technology was used, and the result was one of the greatest innovations of Cheyenne Mountain: rock bolting.
I think it's kind of interesting, not just how they removed the rock, but how they left the remaining rock in place with rock bolts. There aren't too many people that are familiar with rock bolts.
The rock bolts used in Cheyenne Mountain were metal rods, 2 to 9 meters. They were similar to, but much larger, than the common expansion bolts used in normal construction to anchor objects to a concrete or brick wall. 115,000 bolts kept nearly a kilometer thickness of granite from falling in on itself.
Since this facility was designed for dynamic loads that could be induced by a possible nuclear detonation, it was very important that you have a really good rock reinforcement system.
Shock waves move very quickly. We're talking milliseconds. You know, this is not an earthquake type of long frequency. This is a zippo. A shock wave propagates through the rock and hits the interface where the rock and the chamber. The wave creates some tension and tends to take the rock and spoil it. And the bolts and the mesh kept it all together and mobilized a massive amount of rock by tying it all together.
Each bolt was torqued to 40 kilos per square meter. A 2-meter long bolt with a 2.5 centimeter diameter created a tension of 4,500 kilos on the exposed rock face. The tension fooled the mountain into thinking it still had a center. Just as the engineers began to believe that they had conquered the interior challenges of Cheyenne Mountain, a shocking discovery threatened to derail the entire project. They found that the mountain had a fatal weakness.
When they picked the mountain, they thought it was going to be the best mountain in the world, but when they got inside of it, they found it was rotten in the core.
A fractured rock zone was precisely over the tunnel intersection where NORAD's operations center was to be placed.
The collection of joints was known as a shear zone. It was an area where the rock had been sheared apart in ancient geology. If the shock wave had come across the unreinforced chambers with the weak rock would have been squeezed out into the chambers like toothpaste out of a tube and would have crushed the buildings and filled the chamber.
The nearly completed project was in serious jeopardy. Unless the massive natural shear zone could be reinforced, Cheyenne Mountain would be abandoned. As work progressed on NORAD, the North American Air Defense Command Center within Cheyenne Mountain, a fractured rock zone over one of the tunnel intersection project in jeopardy. Unless the massive shear zone could be reinforced, Cheyenne Mountain would have to be abandoned.
I went back to New York and devised a concrete sphere that would be constructed inside the mountain at the intersection of these two chambers. And the sphere could withstand the squeezing pressure of the weak rock being tended to be squeezed out and hold it in place.
The dome, although unplanned, is one of the greatest engineering marvels of Cheyenne Mountain. It took nearly 2 years to complete. The structure for the dome was constructed outside Cheyenne Mountain. Once complete, it was dismantled for the move underground. At 30 meters in diameter, it was a mammoth jigsaw puzzle. Putting the pieces back together again inside the mountain presented Kiesel and his team with another challenge.
The construction of this was more of a problem than the design. The chamber had to be enlarged in order to make room to put this concrete sphere in place.
Expanding the excavation site only added to the instability inside the mountain. Kiesel came up with the answer over lunch while visiting the Army Corps of Engineers headquarters.
I remember sketching this idea out on a napkin in a cafeteria in Omaha. So we came up with a very strong steel tower composed of heavy steel columns laced together, which was jacked up against the roof. You had to bring a 40-foot building to a 15-foot diameter tunnel. So it all came in pieces and all had to be welded together underground in the middle of the cavern. People worked night and day on this.
Despite the added work over the command center, NORAD's interior protective shell was finally completed in May 1965. The steel buildings that would eventually provide 19,300 square meters of working space took their place within the 4 kilometers of tunnel in the cavern. It would take a further 8 months to install the complicated electrical and surveillance equipment inside the mountain. The centerpiece of the new command center was an $800,000 combined camera processor projector that could display a 4 by 5 meter image of the planet in 7 colors. On the screen, radar and satellite information, fed by an array of computers around the world, gave commanders a sophisticated global picture of objects they were tracking. After nearly 5 years of work, and at a present-day replacement cost of $18 billion, the Cheyenne Mountain Complex became fully operational on the 20th of April, 1966. The men who designed, engineered, and built the massive underground center were proud of their work, but they were also quite aware of its limitations. Everyone hoped that the superstructure would never be put to the ultimate test. Even more so, they prayed that it would survive.
The design was based on that premise. Well, the odds were rather high that you would not have a direct hit on the complex. If you had a direct hit, then the dynamic loads would be so great that the openings would collapse. There's just no way to offset the terrible stresses that would be developed in the rock.
In the end, NORAD's survival rested on a principle called circular error probability, CEP. This was simply the probability that a nuclear weapon fired from halfway around the world would fail to make a direct hit on Cheyenne Mountain.
As far as the vulnerability of NORAD, that was really mostly a function of the accuracy of the device. Because, you know, it was a foregone conclusion that a direct hit would destroy it.
From Plesetsk to Kamchatka.
Even though it cannot survive a direct hit, the command center is designed and built to resist the effects of a nuclear weapon. Blast, heat, seismic shock, electromagnetic pulse, and radiation. The access tunnels weaken the effects of blast and heat simply by letting the blast wave pass through the tunnel unimpeded. To avoid a direct strike by the blast wave, the designers placed the blast valves and blast doors at right angles to the tunnels. At the first sign of a credible nuclear threat, the blast doors are closed and Cheyenne Mountain is sealed off from the outside world. Technical Sergeant Marvin Hires and his team of specialists maintain the doors.
Here at NORAD, we have 3 blast doors. The blast doors are designed to protect the mountain from an overpressure, imploding from the inside. Each door's hydraulic system is self-contained, and the speed of the door is anywhere from 40 seconds to 15 seconds if we had to. They're perfectly balanced, 50,000-pound doors. You can actually move them with your hand.
When the doors are closed, technicians reconfigure the ventilating fans to run backwards. The reversed airflow keeps radioactive contaminants or chemical warfare agents from entering the mountain. Another engineering innovation at Cheyenne Mountain is designed to protect NORAD from the seismic shock of a nuclear blast. Massive steel springs, more than 1,300 of them, support each of the 15 buildings in the complex.
Each spring is about this big around, and the wire that makes the spring is 3 inches diameter of high-strength steel. The springs are about 1,000 pounds a piece in weight, and they stand 48 inches tall, unsprung. The weight of the buildings compress those springs to approximately 36 inches. And the purpose of the springs for all these facilities is to prevent a shock that might come through the rock resulting from either a man-made or a natural shock. These springs will attenuate that shock just as they would car springs on your vehicle.
My recollection is that we were just barely able to make one spring out of 1 ingot of steel. Couldn't have made it much bigger than this in the manufacturing facilities that were available.
NORAD's gigantic springs work so well that the concept of seismic shock isolation has been incorporated into many modern buildings in earthquake zones. Flexible passageways and couplings allow the buildings to sway independently without breaking vital connections. But the designers needed even more reinforcement to meet the challenge of a nuclear bomb's electromagnetic pulse, or EMP. The tremendous burst of energy, similar but far more powerful than a lightning strike, can destroy sensitive electronic equipment and damage even sturdy electrical circuits. To combat this effect, the engineers constructed the buildings like the hull of a ship or fuselage of an aeroplane. The continuously welded 1 centimeter thick steel skin gave structural strength as well as electromagnetic pulse protection.
It was found that the pulse could be deflected if the entire building inside was surrounded with a steel shell, just like a ship. So the basic description of this facility was a fleet of upside-down ships constructed in a cave floating on a sea of springs.
The complex facility that lies in the heart of Cheyenne Mountain is never turned off and needs constant support to function. Ben Borth is the Deputy Base Civil Engineer for the Cheyenne Mountain Complex.
There aren't too many situations that our utility system cannot accommodate today. Fortunately, the people that designed and built this place had in mind all of the redundant equipment necessary to operate in the event that a primary water system, electric system, or HVAC, heating, ventilating, air conditioning system would fail. It's the redundancy and the unique design of those types of systems that make this a very interesting place to work.
A reliable source of power is absolutely necessary for the complex network of critical electronic equipment.
Right now we are in the bowels of Cheyenne Mountain. In fact, we're at the lowest excavated point within the complex. Behind me is a 500,000-gallon diesel storage reservoir that we use to power our generators in the event that we need to go to generator power. And this reservoir will permit us to run for an extensive period of time if we should lose commercial power.
Even the backup power has a backup. 3,400 powerful battery cells maintain what is called uninterrupted power supply, or UPS, for the operation of NORAD. It is one of the largest backup power systems ever built. Perhaps the most important supply for the operation of NORAD is water. 7 million litres of drinking and over 20 million litres of industrial water are stored here. Cheyenne Mountain must also regulate its air supply. Air enters through two sources, the north and south portals, and is then directed through a so-called air delay path. This construction is crucial to prevent damage from the force of a nuclear blast and the pressure pulse it would create, a destructive blast of air traveling at the speed of sound. The air delay tunnels are equipped with blast valves, one of the ingenious design elements of Cheyenne Mountain's respiratory system.
If a blast occurs and that pressure pulse drives up the tunnel, that pulse will hit a disc located on the back side of this valve and drive that disc across these slots, preventing any air from entering the complex.
The mountain must also be able to repel chemical, biological or radiological contaminants. To combat these threats, the engineers can force outside air through sophisticated CBR filters in the cooling towers. Cheyenne Mountain is more than just an impressive array of technological wonders. It's a place where people live and work. More than 1,200 people keep the complex functioning 24 hours a day, all year round. At any given moment, there are as many as 800 highly trained people working inside, from a collection of 12 government and civilian agencies, and from the combined branches of both the US and Canadian armed forces. Security is tight, not only getting into Cheyenne Mountain, but also in moving from area to area within the complex. Although always on guard, the complex does have its amenities. Not surprisingly, its engineering makes it a unique and awe-inspiring place for the people who work here.
When I first got to Cheyenne Mountain, to NORAD, I was astonished. The size of it. I had no idea that we had this much room inside the mountain. Being inside the mountain, you really don't get a feeling of claustrophobia because of the space. Inside the buildings, you really, if you were in the same building downtown, you really wouldn't notice the difference, other than not having a window to look out of. It's just like being in an office without a window.
For more than 30 years, the Cheyenne Mountain complex has ceaselessly watched the skies. But was the mission necessary? Today, the Cold War is over. But before the collapse of the Soviet Union, the threat to North America was very real. Their plan for a global thermonuclear war was revealed in a 1985 report. It consisted of a surprise attack that would be launched on several fronts. The Soviet Army, Navy and Air Force would simultaneously attack targets in Western Europe and in North America. The first barrage would destroy US coastal cities and create an electromagnetic pulse that would disrupt satellite and ground communications. They estimated that in the first 20 minutes of the massive nuclear assault, millions of lives would be lost. High on the list of primary targets was Cheyenne Mountain.
They knew a lot about NORAD, and locations of weapon systems include fighters interceptors, missile interceptors, numbers and location of American space satellites, not for something abstractical, but for very real reason, how to destroy this system in time of possible war.
Challenged by Cheyenne Mountain, the Soviets built elaborate subterranean military command posts connected by secret subways.
It was located not very far from Moscow, in highly protected bunkers, very highly protected bunkers, not so strong ground as NORAD is located, but in granite. We never consider this facility like maybe you consider NORAD headquarters as a 100% secured and protected. No, because after first sign of possible attack, this headquarters will be evacuated immediately to another center, which located in much more secrecy and much more protected.
Western intelligence estimates indicate that the Soviets were prepared to shelter as many as 175,000 key officials and support workers, who would rebuild their country after a prolonged nuclear engagement. For nearly 40 years, the world trembled under the cloud of possible nuclear annihilation. But for all the military build-up, Cheyenne Mountain has only once entered an advanced state of alert in its history. That was in October 1973, during the Yom Kippur War, as the Arab allies advanced on Israel. America ordered B-52s, armed with nuclear bombs, into the air. Missile launchers went into a pre-launch check as NORAD monitored the war. The United States military was placed on defense condition, or DEFCON 3, an advanced state of alert. The alert warned the Soviet Union's Arab allies that an invasion of Israel would not be tolerated. The advance was halted and the alert relaxed. Then, in the late 1980s, the Soviet Empire collapsed, and with it, so did much of its nuclear threat. Today, the Cold War is over, and NORAD has been forced to redefine its role. A role that was to be tested to its limits on September the 11th, 2001, when the enemy attacked from within. The North American Air Defense Command, or NORAD, operates the continent's early warning front line against airborne attacks from rogue nations. Today, the same technology stands watch for possible aggression from terrorist organizations looking for American targets. When the first passenger plane was hijacked on September the 11th, 2001, NORAD scrambled 2 F-15 fighters within 6 minutes of losing contact with the plane. Although the attacks on the World Trade Center and the Pentagon weren't prevented, NORAD was able to alert the military to the threat of the ever-increasing menace of terrorism.
You know that international terrorist groups just now are growing like mushrooms after rain. So I think that danger to NORAD is not only still existing, but challenges to NORAD just now much more than it was before or in time of Cold War.
NORAD tracks all aircraft movement in and out of North America, not only to prevent terrorism, but as a weapon in the war against drugs. Thanks to the ever-watchful eyes of NORAD, there have been a number of dramatic interceptions of drug traffickers in North America. NORAD even monitors threats from outer space. International treaties ban the deployment of weapons there, but the Space Control Center tracks every object that orbits the Earth from an altitude of 320 kilometers all the way out to 37,000 kilometers. Nothing goes up into space or falls out of it without the center knowing about it.
We've been doing this ever since Sputnik launched in October of 1957. Object number 1 is the rocket body from that launch. Sputnik is object number 2. We're currently up to 25,484.
Over the years, NORAD has become a valuable asset to NASA shuttle missions.
We'll use the shuttle as an example. While it's on orbit, we will build a 10-kilometer by 50-kilometer long theoretical box inside of our computer. We'll compare that to the 8,200 objects that we're tracking for 36 hours. If any of those objects penetrate that box, we have a hotline to the flight dynamics officer at NASA, and NASA is the one that makes the decision to maneuver the shuttle. In the 91 missions, they've maneuvered 7 times to avoid an object. The support for the International Space Station will be quite similar to what we currently provide for the shuttle. The only difference will be we will have a dedicated person to support that mission, and it will compare all the objects that we're tracking for 72 hours versus 36 hours that we do with the shuttle. They will also use the same hotline to the flight dynamics officer at NASA, and NASA will make the decision whether to maneuver it to avoid an object.
Since its Cold War origins, this engineering marvel has matured to fulfill several important roles in the technologically complex world of computers, space weaponry, satellite communications, and even the colonization of near space by the International Space Station. But those who built the Cheyenne Mountain complex have never forgotten the terrifying times that led to NORAD's construction.
Children were being raised with this nuclear threat over their head. You needed to do something about it.
First, you duck, and then you cover.
When the wall came down, and essentially the U.S. won the Cold War, looking back, I feel, well, maybe I had a small contribution to that total impact. And although it was expensive, it was a lot cheaper in both money and people to go that route than to have a nuclear holocaust.
Today, the risk of global thermonuclear warfare has receded, but not completely disappeared. There is still a variety of threats in the world that necessitates the continued operation of NORAD. Many believe there is no foreseeable end to NORAD's mission. This monument to their ingenuity will continue to serve the security of North America well into the new millennium.